Hello everyone, I'm David Murthy, and today we'll be presenting about nuclear power generation. These are my group members: Sri Mundan, Ugindiran, Harish, Ibrahim Shah, and myself. Nuclear power generation is a major contributor to global energy production, offering a stable, efficient, and low carbon alternative to traditional fossil fuels. By harnessing the energy released from controlled nuclear fission reactions, nuclear power plants are capable of producing large and continuous amounts of electricity, making them sustainable for meeting national baseload energy demands. In addition to its high energy density and reliability, nuclear power plays a critical role in reducing greenhouse gas emissions and supporting long-term climate goals. Despite concerns about radioactive waste, safety, and high operational cost, advancements in reactor design and safety technologies continue to strengthen the viability of nuclear energy as a sustainable component of future power systems.
Hello everyone. Okay, so for today, my part, I would like to talk about the operation, or also can be said as the basic principle of the nuclear power energy. Okay, so if we see in this slide, the main fundamental goal of any power plant is to generate electricity. And the basic process is often the same thing, which is we create heat to produce steam, which spins a turbine connected to a generator. The key difference with nuclear power is the heat source. So instead of burning fossil fuels, uh, we apply the massive power stored inside an atom itself through a process which is called nuclear fission. Okay. So if we look, okay, let's look at this slide. Okay. Now, if we see the heart of the process is, if we can see here the heart of the process, which is a nuclear fission. So, the fuel is basically the pellets of uranium-235. When a tiny neutron strikes one of these atoms, it splits apart. So, this splitting process releases a huge amount of heat energy and also crucially two or three neutrons as well. These new neutrons then fly out and split into other atoms, which will release more neutrons and creates a self-sustaining process called control chain reaction. So this continuous splitting of atom is what generates the steady heat, and it all happens within the reactor core. Okay, so how do we capture this nuclear heat? Okay, this is the job of the reactor coolant system. In the most common type, common type, which is the pressurized water reactor, the core is submerged in water under extremely high pressure. This pressure stops the water from boiling and allows it to become superheated to over 300 degrees Celsius approximately. This water also acts as a moderator, which slows down the neutrons to keep the chain reaction more efficient. This hot and pressurized water is then pumped through a closed loop of pipes, which is called the primary circuit, to a device that is called a steam generator. Okay, now we convert thermal energy to electrical energy. So in the steam generator, the hot the heat from the primary circuit is transferred to a separate, also can be said, a secondary water supply. So this water boils and turns into high pressure steam. This steam is then piped onto the blades of the turbine, causing it to spin at a very high speed. The turbine is connected directly to a generator, and as it spins, it creates electricity through electromagnetic induction. So after passing through the turbine, the spent steam, the balance is cooled back into water in the condenser, and it will be pumped back to be reused, which will make the system very efficient as well. All right. Now, to bring it all together, okay, the nuclear power cycle is one of the most important thing in engineering. So it starts with the fission in the core, generating huge amount of heat, and then the heat is carried by a coolant to create steam, which drives a turbine and generator to produce the electricity we use. And finally, we can say it's a highly efficient, powerful, and precisely controlled method of generating clean electricity. Okay, that's all from my part. Thank you.
Next, we'll discuss about the basic construction of nuclear power generation. A nuclear power plant is made up of several major components that work together to produce electricity. A basic construction is the important part that form the power plant and allow it to operate. Firstly, reactor core. The picture on the top right shows the example picture of reactor core. This is the main part of the plant where the nuclear fission happens. A nuclear fission is also mean splitting of big atom to release heat energy. These contain uranium fuel rod that release a huge amount of heat when atoms split. The core is the heat source of the entire power plant. Next, about control rods. Control rods are long metal rods used to control the speed of nuclear fission in a reactor. Long rods are made of boron or cadmium that absorb neutrons. They work when move in and out simultaneously of the reactor core to control the fission rate. When the rods are completely insert, the reactor slows down. While lifted, the reactor power increases. Thirdly, steam generator and heat exchanger. With the example picture on the top right, it transfers from reactor to water, turning it into steam. The steam drives the turbine and also ensures radioactive water does not mix with the turbine system. Lastly, turbine generator unit. The example picture on the top right converts steam energy into electrical energy and also drives the turbine and also ensures radioactive water does not mix with the turbine system as steam generator. Thank you.
Thank you for the opportunity given to me. Let's talk about the nuclear power generation. Global nuclear fleet, which plays a crucial role in providing baseload electricity. The major contributors include the United States, France, and China. Let's talk about the power reactor vessel and internals, which have the fuel assemblies, control rods, steam generator, and containment. Inside each fuel assembly contain thousands of uranium dioxide pellets. Nuclear power generators have reinforced containment structure which is engineered to withstand extreme external events and internal pressures. Redundant safety systems including the multi-layered barriers, emergency core cooling, and passive safety features. Example site which is located in Malaysia na- named Tenaga Nasional Berhad Station Jana Kuasa Sultan Azlan Shah in Manjung. Key benefits of nuclear power generators provides low carbon emissions, reliable baseload power, high power input, and fuel efficiency. In the future, we can have innovations in nuclear technology. And what are those? Small modular reactors, fusion power, and advanced waste management. That's all from me. Thank you.
Hello everyone. So today our group is going to talk about the nuclear power generation. So my part is about one example of power generation site. So the example we have taken is Chernobyl nuclear power. So basically the plan was designed to generate electrical power for Ukraine and nearby regions of the Soviet Union. At full capacity, it could produce about 4,000 megawatts of electricity, enough to power millions of homes. So the type of reactor is RBMK 1000. It's a Soviet designed graphite moderated nuclear reactor. So there are total of 4 operational units reactors with 2 more under construction at the time of the disaster. So next is we see the description. So the electrical systems that are used, it is connected to 330 kilowatt volt and 750 kilovolt grids, diesel generators and spinning turbo generators provided backup power to essential systems like coolant pumps. Turbo generators. Each unit had two 500 megawatt hydrogen cooled generators with K500 the 65 over 3000 steam turbines, rotor cooled by hydrogen, stator by water. Reactor fleet 4 RBMK 1000 reactors operated. Reactor 5 and 6 were never completed. Reactor 1 and 3 closed by 2000. Reactor 2 was shut in 1991. So the control systems. Scala monitored reactor conditions. Prisma analyzed power and guided operators but could not directly control the reactor.
These are the references used in our presentation. These references helped us know what a nuclear reactor does. It also gave us awareness on the current issues and facts and the definition of nuclear power. It also deepened our understanding on how electricity is generated at a nuclear power plant.